his next idea was to make a remote-controlled model and to use it as a demonstration to promote the idea of a project to make full-scale helicopters. Now, he, with this model, managed to measure rate of climb. He got up as high as 200 feet in the air with it, but of course had to wait for extremely calm weather to do so. There's a nice jump takeoff. You can always see those vanes on the bottom, but the lifting rotor, of course, when it's turning fast, it becomes invisible. So at about this time, he decided to make a really nice remotely controlled model, and here it is. He's going to demonstrate it for us. We'll see him take the cowling off now and show the anatomy. The black thing just above the cowling is the swash plate, and you can also see that harness which is holding it above its center of gravity. Now there's the motor in the bottom and the rotor on top, the flywheel again turning at motor speed, and the rotor 1/13. You can also see the swash plate under there, the black Bakelite object. Now this is a single rotor tail rotor configuration, and the tail rotor is driven by the separate motor in the nose, that little blue motor there. It in turn has its voltage controlled by the flywheel you see there, so that if the model changes direction, the flywheel will precess and change the voltage. Those are the solenoids which control the black swash plate, and there's the harness above the center of gravity. The cable has 9 conductors which control the various solenoids and of course the power of the motors. Notice his hand moving laterally, the flywheel moves fore and aft. But once things are spinning, then the rotor will follow exactly what his hand does, due to the gyroscopic effect, of course. As his hand moves left and right, the rotor will tilt left and right. And now we see that there's quite a breeze here. That's the reason for the smoke. And he is, in fact, able to control the model without having to wait for flat, calm days, and can fly it where he wants to send it. With this model, he went to Buffalo to show it to Larry Bell, whom he had met through a mutual friend. And Larry Bell was instantly fascinated, not only with the model, but with Arthur Young. By the way, notice that landing gear. It's very important because you're going to see a lot of it later. But here's the little wheel landing gear, which was used for the fancy demonstrations in the Bell factory and in many other places. So Larry Bell and Arthur got together on an agreement, and Arthur went to Buffalo in 1941. It was November 1941. I went along with him to help carry the luggage and be his assistant. After the arrival in Buffalo in November 1941, 6 months later, we got a separate project started in the village of Gardenville, New York, in what had been a garage. And here we are illustrating the design part of the project. There's our first transmission drawing. And then, more important, we had an excellent shop right there where we could make the actual parts for the helicopter. For instance, here's our assembly of the first machine. That tail boom was made in a nearby Bell plant. Here is a landing gear very similar to the landing gear that we had on that model which you saw. Now here we're removing the shaft from the tail boom, and we had just been running it up to see if it was okay and the bearings would work and so forth. That pulley to the left there was used to drive it up to full speed and make sure we had no resonance. There's a pretty good view of the garage as a whole and the first test bed really taking shape. There's the mechanism that the first machine had, its stabilizer bar, and of course above it the hub ready to accept the blades. The blades were very similar, by the way, to the model blades. Now, we used very few drawings when we came to things like the fuselage, which was mostly plywood beams, and we improvised as we went along, of course. Naturally, we had to have drawings for control parts and transmission and so forth, but for instruments and things we considered unimportant for tolerance purposes, we simply improvised as we went along. Now here's the same boy who had learned how to make the model blades in mass production, making full-scale blades to almost exactly the same design. They're solid wood. That cam causes the saw to follow, make an airfoil shape. The leading edge has a metal insert, as the model blades had had. We made two different airfoil sections before we were through, the 0012 and also a 23012, which was not as easy to smooth out as 0012.